Hi guys, question 4. We have f of x, we have g of x, and it says find the range of f. Okay, so that's for part A. So f of x is 6x squared minus 12x plus 1. You could, so this is a quadratic obviously. It looks something like, well, I'm not entirely sure what it looks like yet, but we have a calculator. You could find the minimum, and you could probably draw that without a calculator, but we do have a calculator, so let's just draw it. This is paper 2. Remember guys, paper 2, use your calculator as much as, well, as much as you need to in order to help you. So it looks something like this. You can trace it, graph trace to see, look, the y-intercept is 1, the 0 is just kind of, well, it's near 0, another 0 there. You certainly don't have to draw it perfectly, but what's important is the minimum. The minimum is at 1, -5. Now you could figure that out using the various formulae that you have, or differentiation or whatever, but hang on a second. Let's go down like this, and let's just go up by that. So what's important is this point. This point is at 1. That's at 1, -5. Okay, if that's at 1, -5, what's the range of f? So the range, remember, is the y values. So the y values, and by the way guys, that is, some people are going to say, what working will I show here? Well, this is the working, the graph. So you've seen this is the graph, 6x squared minus 12x plus 1. So f of x has to be, it's always going to be bigger than this. The y value is going to be bigger or equal to this minimum, which is -5. So f of x is greater or equal to -5, and that's it. Done. Part B. Given g of f of x is less than or equal to 0 for all x as an element of the real numbers, determine the set of possible values for c. Okay, the first thing I want to do, guys, is get g of f of x. So g of f of x. So that means I'm putting f, I'm subbing f into g. So it's minus, now instead of x, I'm going to put f, 6x squared minus 12x plus 1. And then there's this plus c. And this gives me minus 6x squared minus 12x. Sorry, what am I doing? Plus 12x minus 1 plus c. So minus 6x squared, minus times minus is plus, minus times plus is minus. Okay, so this is g of f of x. Now what I'm going to do, guys, and I've seen the mark scheme, there's various different ways to do this. None of them actually show a graph, which I think is the kind of the best way to do it. So what I'm going to graph is now actually the negative version of this. So I can actually do it kind of straight away. I'm going to forget the, sorry, tab. I'm going to forget the c, but I'm going to do the negative of this. So minus, put a bracket here, put a bracket here, press enter, and we get this. Now guess what the maximum here is going to be? Well, you should know that, guys. It's going to be 5, because we've just flipped it on that x-axis. So the maximum is at 5. So I'm going to actually draw, oh, there we go, nice. I'm going to draw this point here, and this point is 1, 5. But this is the graph of y equals minus f of x, not the plus c. But this is good working to help us understand what's happening. So this is obviously not less than or equal to 0 for all of x. It's bigger than 0 from here to here. But it says, all right, we have a c in it. So this is just this bit, and there's a plus c. So it's basically saying, what are the values of c that will make this less than or equal to 0? So imagine if I was to pull down this graph, so that, okay, hang on, let me leave that there and copy this. All right, if I was to pull this graph down so that the whole thing was less than or equal to 0, essentially it has to be either here or anything less than here. So what must C be to bring this thing down to here? Well, it has to be at least, I have to subtract at least 5 or anything more than 5. So that's why C, I can just say then, therefore C has to be less than or equal to 5, because that way it'll bring the whole quadratic underneath the x-axis, which means that the whole of g of f of x is less than or equal to 0. Okay, hope that makes sense, guys. I'll see you for question 5.